Okay, the things you should have out on your desk at this time are the worksheet from last night's assignment. This is Friday's assignment. So have this out and have today's assignment out. So if you were not here, you should have picked one of these up already from Mr. Pazzi. Then he would have handed this out to you guys already as well. Okay, so I'm going to put this aside and we're going to talk about last night's homework first. So I'm sure it was confusing a little bit. We didn't have a whole lot of time in some classes to go over this piece. So I do want to take some time going over that now. Make sure your information's filled in here, your score is here once you have everything done. All right. I am going to do number 1 with you. And I'm hoping at the very least you've already plotted your points. A is -10, -8. B is -10, -4. And C is -7, -8. All right, so you would have plotted A, B, and C. And sorry, the other thing you should also have out on your desk are rulers, which would have been handed out, should have been handed out to you already at this time. Okay, so this should have been done already. Here's your right angle. You can tell it's a right triangle because we have a vertical line, and a horizontal line. All right, dilate triangle ABC by a factor of 2 using -12, -10 as the center of dilation. So -12 down to -10. All right, now if you were here on Friday, what we talked about is kind of using slope, rise over run, and just continuing it a total of 4 times. If you were not here, then this is pretty much what we did in class. It doesn't matter which point you start with, I'm just going to go in order. A first. So from my center of dilation to point A, I go up 2 and right 2. So I'm going to do that a total of 4 times, counting the first one. Up 2 over 2, that's 1. Up 2 over 2, that's 2. Up 2 over 2, that's 3. And up 2 over 2, that is 4. And that puts me at -4, -2. And that is A prime. All right, I'm going to do the same thing with C. From my center of dilation, up 2 over 1, 2, 3, 4, 5. Count it yourself, see if it's up 2 over 5. And then you're going to do that a total of 4 times, counting the first one. And the first one should always end up putting you at your first spot. So up 2 over 5 puts me at C. I'm going to do it again. Up 2 over 1, 2, 3, 4, 5. That's my second time. Up 2, 1, 2, 3, 4, 5. That is my third time. And up 2 over 1, 2, 3, 4, 5. That is my fourth time, which puts me at 8, -2. Okay, so you do the same thing now with B. I know I said I was going in order and I did not, but it's fine. B is up 1, 2, 3, 4, 5, 6 over 2. Count yours and see if it is the same. All right, we're going to do that a total of 4 times again because the scale factor is 4. 1, 2, 3, 4, 5, 6 over 2, first time. 1, 2, 3, 4, 5, 6 over 2, second time. 1, 2, 3, 4, 5, 6 over 2, third time. 1, 2, 3, 4, 5, 6 over 2, and it's kind of in that box, so that would be -4, 14. Okay. So that is my A prime, B prime, and C prime. And this one here is the B prime, sorry. B prime. All right, so let's connect. Okay, so you can see with the scale factor of 4, it should be enlarging in size. If your scale factor is bigger than 1, your shape is getting bigger, your dilation is getting larger. If your scale factor is smaller than 1, like a half, a third, 2/5, your image is getting smaller. But this one is getting bigger because this is the original and this is the new. All right, now this box piece I didn't go over with all of my classes, so I want to make sure everybody's paying attention and you're making sense of it now. Find the perimeter and area of each triangle. Okay, in order to do that, I need to know all the lengths of all my sides. So AC is 1, 2, 3. So I'm just going to label that 3. A is 1, 2, 3, 4. I'm going to label that 4. And how do I find the length of BC? We use Pythagorean's theorem, which is a squared plus b squared equals c squared. So that gives me 4 squared plus 3 squared equals c squared. 4 squared is 16, plus 3 squared is 9. 16 plus 9, add that together. 25 equals c squared. And you undo a squared by square rooting both sides. No plus or minus on this one because it's a side length of a triangle. C is 5. So the length of my hypotenuse is 5. Okay, I'm going to go ahead and find all those pieces for my large triangle. I'm going to give you guys a few seconds right now to find the length of AC by counting and find the length of AB by counting. Go ahead and do that now. Okay, I'm hoping everybody got the length of A prime C prime is 12 and the length of A prime B prime is 16. And you can find that by counting. And how do you find the hypotenuse? You do A squared plus B squared equals C squared. So that's 16 squared plus 12 squared equals C squared. We have some big numbers here. If you don't have calculators in front of you, that's okay. But when you're working on this on your own, like on homework or quizzes or tests, you just plug the numbers in. 16 squared is 256. 12 squared is 144. And when you add those two together, again, if you're not doing it right now with the calculator, don't worry, you can plug it in later. 400 equals c squared. Square root, and the square root of 400 is 20. So the hypotenuse here, the length of BC is 20. Okay, now when you find scale factor, and I did say this in some of my classes and not all, when you find scale factor for specifically dilated images, for dilation specifically, your scale factor, I'm going to squeeze it down here, will always be the length of one of your new sides over the length of one of your original sides. And it doesn't matter which length you pick, the base, the height, or the hypotenuse doesn't matter as long as you match base with base, height with height, hypotenuse with hypotenuse. And when you divide, you should always not large over small or small over large or right over left. It's always new image over original image. So let's pick a side. Let's pick the base. My new base is 12. My original base is 3. What's 12 divided by 3? 4. So your scale factor is 4. And was it the scale factor that they gave us? Sure enough, it is. Let's check this one. Height is 16. Original height was 4. New over original, 16 divided by 4 is 4. Look at your hypotenuse. Original hypotenuse, new hypotenuse, sorry, is 20. Original is 5. 20 divided by 5, lo and behold, it is 4. Scale factor of 4. And we did talk about last week, I did talk with all of my classes about corresponding side lengths being parallel. You do need to know that for the test. Corresponding side lengths are not congruent, but corresponding side lengths are proportional as well as parallel in dilations. All right, so let's answer these questions in here. Find the perimeter. 5 plus 4 plus 3. Add those together now. 5 plus 4 plus 3. We get 12 units. Perimeter of the larger image is 16 plus 12 plus 20. Do that now. And it is 48 units. All right, for the area, in order to do the area, you need to know that area is 1/2 base times height. 1/2 base times height. So we have, let's do this one first. Area equals 1/2. The base is 3, the height is 4. We don't use the hypotenuse on a right triangle when you're doing area because your base and your height have to be perpendicular. Base and height are perpendicular, so 3 and 4. So 1/2 of 12, the area is 6. And I'm going to go ahead and put units squared because we don't know the units, meter squared, inches squared. In this case, the little units squared. All right, area for the larger triangle is 1/2 base times height, base being 12, height being 16. Once again, we don't use the hypotenuse because your base and height should always be perpendicular. 12, 16. All right, 12 times 16. And 12 times 16, you'd plug in your calculator or you would do it by hand. Because of time, I'm going to give it to you for now, knowing you can calculate it on your own later. And 1/2 of 192, if you were to plug in, you would do 192 divided by 2 or 192 times 0.5. Either way, the area comes out to be 96. 96, again, I'm going to write units squared, square units. Okay. Now it says, what is the scale factor of A, B, C, D to A prime, B prime, C prime, D prime? Now, didn't catch it initially, but this is flipped around. This one should be coming first. That is definitely a typo. It should be coming first because we always do the new over the original. All right, so it should be A prime, C prime, D prime, and this shouldn't even be a D in there. There's multiple typos. A prime, B prime, C prime to A, B, C. All right, just remember, typo or no typo, it's always new image over original image. So it's, when you're looking for the scale factor, you pick any side length. We have all 3. I'm going to randomly pick one. I'm going to pick the 12. So the new image is 12. The original base length is 3. And what's 12 divided by 3? It is 4. And indeed, is that the scale factor? Not a coincidence. It is. All right, now think about it. 12 times 4 is 48. Did the perimeter get 4 times bigger? It did. Does that mean the area gets 4 times bigger? Is 6 times 4 96? It is not. So let's figure out what's going on there. What is the ratio of the perimeter? Again, new over original. The new area, oh, I put these in the wrong spot. Gosh darn it. Nope. I did not. I just jumped the gun. I'm going to take a few steps back. So this is 12 over 3 and it's 4. It's a scale factor. It's good. And 12 times 4 is 48. So let's write that in the perimeter area. 48 is the new perimeter over the original perimeter is 12. 48 over 12. And if you divide and you plug in your calculator, 48 divided by 12, 48 divided by 12 equals 4. And that's the one I was trying to say, not a coincidence, that your perimeter got 4 times bigger because that is the scale factor. So 12 times 4 is 48. And then we said, does it happen with the area? It did not. So let's check it here. What is the ratio of the area? New over original. New area is the big image, and that is 96. Over original area is the small image, and that area was 6. And we plugged it in our calculator to divide. That's 96 divided by 6 equals 16. So why in the world would the perimeter get 4 times bigger but not the area? The reason is area is units squared, or square units, so you're squaring. So what's the scale factor? 4. And what's 4 squared? It's 16. So if your scale factor had been 3, the perimeter would be 3 times bigger, but your area would be how much bigger? I'm going to repeat that. If your scale factor was 3, the perimeter would just get 3 times bigger, but your area would get how much bigger? 9, because 3 squared is 9. All right, that's all I'm going to do with you on this page. I'm going to have you do this, this one on your own. There's no area and perimeter. It's just drawing and dilating. I'm going to have you do this one on your own, very similar to this first one. You're going to, well, it's not a triangle. I believe this one is a rectangle. And you're going to dilate. Try them on your own. Get them done. All right. I am going to, but this part here, this whole perimeter increases by the scale factor and area increases by the scale factor squared. You do need to know that for the test. So make sure you study, and I'll go over this with you when I come back as well. Okay. I'm going to have you flip over to the back page. And I want to go over a few of those with you, actually most of this with you. So let's quickly get this done. All right, DEF is a dilation of ABC. So DEF is the dilation of ABC. Can you see that? This is the new because it's the dilation of the original. Is a dilation an enlargement or reduction? If ABC is the original and we dilated it to DEF, that is definitely an enlargement. What is the scale factor? Now remember we said earlier the scale factor for dilations will always be new over original. The dilation of the scale factor will always be new over original. Pick a side length. It does not matter which side length. Now right now I'm not going to use a hypotenuse because that's a little harder to find, but I can either pick DF over AC or DE over AB. I'm going to pick DE over AB. So count the length of your DE right now. Go ahead and count that. Okay. When I counted, I got 9. Now I have to do it with its corresponding side, which is its parallel side here, and that is AB, which is 3. And 9 divided by 3 is 3, so the scale factor is 3. All right, because 9 divided by 3 is 3. Now, we said this earlier, if your scale factor is bigger than 1, it's going to be an enlargement, and this definitely is an enlargement. All right, perimeter. In order to find the perimeter, we need to find the lengths of our sides. So I'm going to give you guys just a few seconds to find AB, AC. Don't worry about the hypotenuse yet. DE and DF. Do that now. Count, 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 and count. Don't worry about the hypotenuse. Okay, I'm hoping you found that this was 3, this was 4, DE is 9, and DF is 12. Now we did the 3, 4 earlier on this side. 3, 4, the hypotenuse is 12. That's always the case. If your legs are 3 and 4, your hypotenuse is always going to be 5. Now 9, 12, you'd have to do your Pythagorean theorem. 9 squared plus 12 squared equals c squared. 81 plus 144 is c squared. Again, you could plug that in your calculator later. 81 plus 144 is 225 equals c squared. Square root both sides. And you either have it memorized or you plug it in your calculator. C equals 15. Okay, find the perimeter of ABC. Okay, so the perimeter of ABC is 3 plus 4 plus 5. Do that now. Good, it is 12. Area of ABC, I'm not going to do the area yet. I'm going to have you do perimeter of DEF. Do that now. Perimeter of DEF, 9 plus 15 plus 12. Do that now. Okay, should have come up with 36. Now let's see if what we said on the other page worked out. For your perimeter, it just should increase by the scale factor. So let's see if it did that. 12 times the scale factor, which is 3, equals 36. And indeed, it is the, see if I can get it in there. It is indeed what we came up with. So this increased, or got 3 times bigger. 12 times 3 is 36. Put a little note there, 12 times 3. All right, area of ABC, half base times height. Area equals half. Base is 4, height is 3. Or you can think of the base as 3 and the height as 4. It does not matter as long as the base and the height are perpendicular. 1/2 times 12 equals 6 units squared. Area of DEF. DEF is half the base, which is 12, times the height, which is 9. Or you can put the 9 as your base and the 12 as your height. It does not matter. Multiplication is commutative. And 12 times 9, I'm going to give to you, but you can plug in later, is 108. And you take half of 108 and you get 54. 54 units squared. Now what did we say on the page before? If the perimeter just gets 3 times bigger because that's your scale factor, would this get 3 times bigger? We said no, you square the scale factor, and what's 3 squared? 9. So let's see if that did happen. Oh, we don't need the calculator for that. What is 6 times 9? Is 6 times 9 54? Yes, it is. So indeed, the perimeter got 3 times bigger because that's the scale factor. The area got 9 times bigger because it's the scale factor squared, and area is always squared, units squared. Need to know that for the test. Okay. What is the relationship between the perimeter of similar figures and y? I'm just going to say it, and you're going to listen, and you're going to write it down now or later. It's up to you. Well, we just discussed it here. What is the relationship between the perimeter? It got how much bigger? The perimeter got 3 times bigger because that's the scale factor. 12 times 3 is 36. What is the relationship between the area? The area got 9 times bigger. 6 times 9 is 54. Because the scale factor is 3 and 3 squared is 9. Got it? Think about it. You can write it down later. Okay, I do want to talk about this one quickly. actually, I'll let you do this one on your own. I do want to talk about what you're going to need for today's lesson. Before we pull that worksheet out, the notes for today are pretty much, we're going to use this same piece of paper here, and here's what we're going to do. On today's lesson, we are going to look for the center of dilation and scale factor. We know how to find the scale factor already using this, a length of your new side over a length of your original side. And you always want to use vertical or horizontal side lengths because those are easy to count versus diagonal like hypotenuse sides because those are a little harder to find. Okay, so here's what you do. We're working backwards now. So make sure you have your ruler ready. What you do is you line up A with A prime, B with B prime, and C with C prime. And you connect the dots. So A with A prime, you get your ruler, you line them up, and you connect. Do you see what I did? I didn't need to make my line that big on this side, but I just want to make sure I connect A with A prime, and I made a nice long line. Okay, then I connect B with B prime. So you want to be as accurate as you can be. You want to make sure that it's right on those dots. B with B prime. I just held my ruler up to B and B prime and I connected. And now I'm going to do the same thing with C and C prime. So again, I just want to make sure that when I put my pin here, I hold my ruler over so I can get as accurate as possible. And I connect C with C prime. And when you are done, you should see that all three lines intersect beautifully right there at the point of dilation. So that will work every single time. Okay, let's try it on this side over here. They gave us the point of dilation. Let's see if that works. Okay, it's not A and A prime, it's A matches up with D. So I'm going to match A and D. Make sure my rulers are at those corners, and then I'm going to connect. And C matches up with F, C and F. So I'm going to make sure my ruler matches up with the F and with the C. And I'm going to connect. And then B matches up. Where's B? B is the middle, E is the middle, so B and E. That's a vertical line that's pretty easy to line up. And lo and behold, that those three red lines intersect at the point of dilation. Yes, it did. Okay, so that's what we're going to do. That's pretty much the notes for today's lesson. So before we get working on today's assignment, I want to make sure you guys understand that if you did not get this done, you're finishing this tonight. So you're doing number 2 right in this section. You're doing number 3 over here. You're filling this in. I gave you the answer. You're filling it in, and you're trying number 5 on your own as well as number 6. Okay, I'm going to put this aside. And I'd like you to take out tonight's assignment. That's this one here. I'm going to do 2 of them with you, and then you're going to finish the rest on your own. And there's only one side, so it's really not all that hard. Okay, I am going to do number 2 with you first. So fill in your information here. When you are done, you'll give yourself your 5. Okay, so I'm going to line up A with A prime, B with B prime, and so on. Okay, so you want to be as accurate as you possibly can. Get those corners in there. Okay, so my line went through the corner A prime and the corner A. And why am I doing that? Because I'm looking for the center of dilation, and then I'll be looking for the scale factor as well. Okay, so you lined up A with A prime and connected. Okay, if you're doing it with me, I'm going to do B and B prime next. And again, I want to make sure that I get it so that both corners are right on my ruler and connect. I can see so far they intersect right there at 0, 1, but I do need to continue connecting just to make sure that is a correct spot. See, I've done A, B. Let's now try C and C prime. Again, get as accurate as you can be. Make sure both corners are right on your ruler. And you can still see it's still working. It's still at 0, 1. And now I'm going to try D and D prime to make sure this is my final checker. D with D prime. Make sure your corners are there lined up right with the ruler. And sure enough, let that come into screen. All three lines intersected right there at that point, which is 0, 1. So when they ask you on the test or on homework tonight, what's the center of dilation for this one, you would say it's the ordered pair 0, 1. Now, scale factor. You want to make sure, I'm going to write it up here, scale factor equals new length over original length. It does not matter which side you pick as long as it's a vertical or horizontal side. For example, on this one over here, I wouldn't pick AB and A prime, B prime. I would pick this right here, like AC or A prime or AC prime. Right here, and I just realized it right now, there should have been a little A prime. So if you can add that there should be an A prime in this same corner. That dot is shared by A and by A prime. And I didn't realize that when I wrote the worksheet. So if you can please add it in right now. A and A prime are that same dot. Okay, so back to this one. Since all of my sides are vertical or horizontal, it doesn't matter. Pick one. I'm going to pick AB. Now remember, it's original. It's new over original. Now which one, on all of these images, your primes are your new image. So this is my new image because it has A prime, B prime. Do you see that? Versus this is my original because it has AB. New over original. So new length here is 2. Original length here is 1, 2, 3, 4. And 2 over 4 is not 2. 2 over 4 is 1/2. Now, what would have happened if instead of AB you picked BC? Would we get the same answer? I'm going to do a quick check, and just remember it's new over original. New are your primes, 1, 2, 3, 4. Original is your non-primes, 1, 2, 3, 4, 5, 6, 7, 8. And what does 4 over 8 reduce to? 1/2. So indeed, it does not matter as long as you're using corresponding side lengths. The scale factor is 1/2. So find the center of dilation, 0, 1. Scale factor is 1/2. Okay, so this is your work here on the side. This is your work with all your lines in the picture. Okay, the next one I'm going to do with you is number 3. Okay, now A and A prime are in the same dot. This one I did remember to put in there. So I don't have to draw any lines because they are the same dot. Now that should be kind of pretty obvious on that one. No lines because it's A and A prime. Now B and B prime, can you see that they lie on that same black line that's there? So really, when I draw it, it's just ending up that same line. Okay. What else do I have? D and D prime. When I line up the D and D prime, it's this dark horizontal line that's here. And so far, these 2 points are intersecting right, those 2 lines, sorry, are intersecting at the same point that A and A prime lie on. Let's intersect with C and C prime and see if we get the same thing. Make sure those 2 corners are on your ruler. Okay, so I have my 3 lines, 1, 2, 3, and my 4th one would be A and A prime, but it's that dot, it's right there. So that ends up being your center of dilation. Why? Because when I draw all of my lines, they all intersect at that point, which is -7, comma, -2. Okay. So you'll do the same thing here, C with C prime, D with D prime, B with B prime, A with A prime. It looks like it's going to be within this square right here. You'll do the same thing here, X with X prime, Y with Y prime, and Z with Z prime. And the same thing here, the same thing here. I do want to talk about scale factor. Now, when I do my new over original, I don't want to pick a side length like AB or A prime B prime because it's not an easy one to count. You can find it, but it's not easy. So I am going to do a vertical side or a horizontal side. I'm going to pick these two only because I can see them. They're easy rather than the overlapping ones down here. So I am going to put new over original. Now, keep in mind, your new is not always going to be bigger, like this one is. This is my new, and it's bigger than the original. But over here, the new was smaller than the original. So keep that in mind. It's not always big, small, small, big. It just depends on where your primes are. Okay, so new is the primes. 1, 2, 3, 4, 5, 6, 7, 8, 9. Original is the non-primes. 1, 2, 3, 4, 5, 6. So C prime, D prime length is 9. CD length is 6. Divide top and bottom by 3, and 9 divided by 3 is 3. 6 divided by 3 is 2. So your scale factor is 3/2. Okay, so think about it. We said earlier if the scale factor is bigger than 1, you're getting larger. 3/2 is bigger than 1. 3/2 is 1.5. So if this is the original, this little one in here, the outer one, which is the new, is 1.5 times bigger, which it did, it got larger. And we said if the scale factor is smaller than 1, you're reducing in size, you're getting smaller. So take a look here. This is the original image, ABC, and it shrunk in size by 1/2, and this is the new image here. It got half the size, which it is smaller. Okay, so today's assignment is doing exactly what we just did for these two, for numbers 1, 4, 5, and 6.